Hi there. Okay, we're going to start chapter 5. Today we're going to do 5.1 graphs of sine, cosine, and tangent functions. So by the end of the lesson, you should be able to sketch f of x equals sine x, f of x equals cos x, and a new one, f of x equals tan x. But the difference is that x is going to be an angle in radian measure. And you should know some of the properties of these graphs as well. So for the graph of f of theta equals sine theta between negative 2 pi and 2 pi, we're going to generate a table of values and then we're going to graph it. So this graph, you should be quite familiar with the shape of this graph and the properties of this graph. The only thing that we're doing differently is, of course, we are graphing in terms of radians, which means our independent axis, our x-axis, is going to be in radians, in this case exact radians, as opposed to degrees. And we could have our x-axis in terms of approximate radians as well. But we're saying here that theta is an element of this domain. If I said theta is an element of negative 6.28 to 6.28, then you know that you should be using approximate radians on your x-axis. Okay, so let's see. What is the sine of negative 2 pi? Well, I know that negative 2 pi goes all this away for 2 pi radians. And so I'm going to be at sine of 0, and I know that the sine of 0 is 0. So far I got 0. Negative 3 pi by 2, that lands me at pi by 2, and I know the sine of pi by 2 is 1. Negative pi, I know the sine of that is 0. And negative pi by 2 lands me there, and I know that that is negative 1. Back to 0, so that's 0. Back to pi by 2, 1, 0, negative 1, etc., etc., etc. Okay? So I've got my table of values, and then I can graph this. So negative 2 pi is 0. And we're going, when we graph this, we're going every quarter of the period. The period of the sine graph is 2 pi. So we're going to, every quarter of that, which is every pi by 2, we are going to plot a point. So here I go. Okay. And then I would draw as nice a curve as I can. No points. Smooth if you can, but this is going to be a bit of a disaster with this stylus thing. So I would expect that yours is going to be much nicer. Oh, see, that's way too pointy. Okay, if I were to ask you to just graph y equals sine theta, I would expect arrows on the end of the graph, but because it gave you the domain of negative 2 pi to 2 pi, we stop at those x values. So I do want you to label 5 points whenever you're graphing sine, cos, or, well, sine or cos. We'll talk about tan when we get there. So this is the point 0, 0. This point up here, we've gone over pi by 2, so that's our x, and we've gone up 1. Over here, we've gone up over pi, and we're at 0. Over here, we're at 3 pi by 2, and negative 1, and then back here at 2 pi and 0. I would expect you to put the equation on there somewhere, and we're good. Let's talk about some properties. The maximum value, of course, is 1. The minimum is negative 1. The amplitude, which is a distance from the middle of the graph going horizontally, if you will, to either the max or the min, is going to be 1 unit in this case. If it were a word problem, it might have units like centimeters or something. But for now, we'll just put the generic unit. The period. The period is the length of time it takes for the graph to start repeating. So it's the length of one cycle. We can see that it repeats. If we started here, we can see that we go to here and then it starts to repeat, and you know that the pattern is 2 pi units long. So I'm going to put 2 pi, in this case, radians. The domain of this graph is negative 2 pi to 2 pi, but the domain of the function itself, f of theta equals sine theta, is going to be theta is an element of negative infinity to infinity. This graph does go on forever, and the range of the function goes from the least value, which is negative 1, to positive 1. So I'm going to say f of theta is an element of negative 1 to, oopsie, it should be square bracket, negative 1 to 1. Okay, so those are some of the key characteristics of the sine function. Why don't you pause the video and go ahead and graph cosine function for me, the next one. Okay, so for cosine function, you should all remember from last year that cosine function really is the same as sine function, except that it is a phase shift. It's been shifted 90 degrees, if you will, one way, and so you should know that, but we just go ahead and graph it anyway based on our table of values. And so if we do that, cos at negative 2 pi is 1. The cos at negative 3 pi by 2, which is really pi by 2, is going to be 0. Negative pi, that's negative 1. Negative pi by 2 is 0. 1, 0. Negative 1, 0, and back to 2 pi, and we're at 1 again. Okay, so you're just using your unit circle to generate all of those values. Okay, so when we plot this, start off here at 0, 1, and then pi by 2, 0, and then pi and negative 1, 3 pi by 2 and 0, and 2 pi is at 1. And if I go backwards, it's going to be here, here, negative 3 pi by 2 is 0, and negative 2 pi is 1. So again, I don't want to see, oh my goodness, any points. It's smooth. Okay. All right, so 5 points labeled. I don't care which 5. So this is 0, 1. This is pi by 2, 0. This is 3 pi by 2, 0. This is 2 pi and 1. And down here we've got pi and negative 1. Okay, so 5 points. This is f of theta equals cos theta. And because these two graphs are really just essentially phase shifts of each other, the key characteristics are similar. So the maximum is 1, the minimum is negative 1, the amplitude is 1 unit, and the period's the same. So that's 2 pi radians. The domain of the function is just theta is an element of negative infinity to infinity, round brackets, and f of theta is an element of square bracket, negative 1 to 1. So all the same. If I asked you what the zeros were, they would be different, but these characteristics that we're discussing are all the same for both of those. Okay, now we're going to do tan function. So tan is quite new. It's different, very different than sine and cos, and let's see if we can generate the table of values. So we know that we're just going to use what we know about tan theta, and that is that tan theta is sine theta over cos theta. And so we'll use our unit circle again. So this is going to be 1, 0, 0, 1, negative 1, 0. We'll just write it out so we can visualize. Okay, so at negative 2 pi, which is this away, we're going to have sine over cos. It's going to be 0. If I go just to here, that's going to be sine over cos, which is undefined because of division by 0. We can't have 1 divided by 0 in math. 0 divided by -1, well, that's 0. -1 divided by 0, undefined again. Do you see a pattern happening here? Back over here where it's 0. Undefined, 0. Undefined, 0. Okay, so let's graph that. What does it mean if the graph is undefined at all of these values? Well, it's just an asymptote, right? The graph cannot cross at that place because it is not defined at those angles. So at -3 pi by 2, maybe I'll just cheat and use a line tool here. I'm just going to draw an asymptote in. Okay, and let's just make it green and make it, okay, and I'll clone it. Okay, so I'm going to have another one at, where did I say? Pi? No, -pi by 2. And I'm going to have another one. Oh, goodness, I thought I locked that. I thought I cloned that. Oh, infinite cloner. There we go. Okay, so now I have to, I'm going to have another one at pi by 2, and I'm going to have another one at 3 pi by 2. Okay. So the other thing that we know is that we have 1, 2, 3, 4, 5 zeros. So I'll go ahead and draw those in blue. And so there's one here. There's one here. Here at 0. Here at pi. And here at 2 pi. Okay. We don't have really enough information to draw our graph at this point. But what I would like you to think about is, okay, let's think about some other points. What's halfway between 0 and pi by 2? Well, that's pi by 4, right? And can we figure out what the tan of pi by 4 is? So pi by 4 is up here. We know that's 1 root 2. And so the tan of pi by 4, opposite over adjacent, is 1. This is, and if you can't figure out this value here, go back. This is the trick that I use. I go back to the very first one, the very first increment. I can see everything's going up by pi by 4s. So I count 1 pi by 4, 2 pi by 4, 3 pi by 4. So this is 3 pi by 4. And I will reduce that if I can. 2 pi by 4 is not, is reducible, and so I call that pi by 2, right? So this is 3 pi by 4, 4 pi by 4, 5 pi by 4, 6 pi by 4, better known as 3 pi by 2, and 7 pi by 4. So I'm just going to fill in the blanks here, and that'll help me to use my special triangles to figure out what these are. So -5 pi by 4, 6 pi by 4, 7 pi by 4. Okay. So I know that pi by 4, the tan of pi by 4 is 1. The tan of 3 pi by 4, which is over here, is going to be -1 because I know tan is negative in that quadrant. So here we go. We'll go down here. So tan of 3 pi by 4 is -1. 5 pi by 4, that's over in the third quadrant. I know that tan is positive in the third quadrant, so up we go. And I know over in the fourth quadrant, it's negative. Okay, and then let's go backwards here. Negative pi by 4 is down in the fourth quadrant, so that's negative. -3 pi by 4, that's in the third quadrant. We know that's positive. -5 pi by 4 is, let me think about that. We're going this way. No, sorry, we're going this way. -5 pi by 4, that's in quadrant 2. And that's negative. And -7 pi by 4 is all the way over here in the first quadrant, so that's positive. Okay. So now if we thought about an angle bigger, I'll just do one example for instance. What's an angle then between pi by 4 and pi by 2? How about pi by 3? What if I wanted to put pi by 3 in here somewhere? I know that pi by 3, the tan of pi by 3, if I drew my special triangle, is root 3, 2, and 1, and the tan of pi by 3 is opposite over adjacent, so it would be root 3, which is greater than 1. So what's happening here is that it's getting closer and closer to this asymptote, and down here it's doing the same thing, because this would be negative root 3 over 1 as we go down here. So I'm going to draw this as though it's getting closer here. So I'm going to come from up here. Oopsie, I'm red here. I'll just change it to blue. I'm going to kind of do that, you know, that sort of dipsy doodle thing we did in polynomial functions? I'm doing that again. Okay, so I'm coming from approaching. This is hard for me to do. I want you to look in your textbook to see the, or go on Desmos to see what the actual graphs look like. So we've got these sort of pieces. Oh, that one was terrible, sorry. So it kind of flattens out there. Okay, it's the best I can do with this silly stylus. All right, so what do we got here? Let's look at some of the properties. The maximum and the minimum. Well, there's no maximum. This goes on forever, as you can see with the arrows. So no maximum, no minimum, goes to infinity. Amplitude, same thing. Okay, it goes on forever, so there is, it's not applicable. You'd say no amplitude. The period, well, how long does it take for one of these to repeat? So there's one cycle here, so it goes between pi by 2 and 3 pi by 2, and if I subtracted that, 3 pi by 2 minus pi by 2 is just pi, so the period is pi radians. The equation, the asymptotes. All right, so here we go. I know that, I'm just going to use a little pen here. I have to label these asymptotes. So theta equals negative 3 pi by 2, theta equals negative pi by 2, theta equals pi by 2, theta equals 3 pi by 2. So if I am trying to figure out what the general equation is for the asymptotes, I want you to think about taking a number like n, which is an integer. So if n is an element of the integers. And then what am I going to do to n? What does every one of these have in common? Well, they all have a pi in them, so I'm going to take my n and I'm going to multiply it by pi, and then I'm going to divide by 2. Well, let's see how we get here. Does this generate our equations? So if I have n is an integer, like 1, 2, 3, 4, 1 times pi divided by 2 is pi by 2. Okay, well that gets me the first one. That's good. But then n is, what if n is 2? 2 times pi divided by 2, well that's pi. That doesn't get me where I want to go, because that's giving me this, the equation of this line, and that's not an asymptote. What I need is, let's look, negative 3, negative 1, 1, 3. I need to generate odd numbers. This n is generating all numbers. So how do you get an odd number from an integer? I can get an even number super easy, 2n, right? If I wrote 2n, then when n is 1, my number would be 2. That's even. When n is 2, 2 times 2 is 4, 1 is 3, 2 times 3 is 6. Okay, that's easy. How do I get the odd number though? Well, all I have to do is subtract 1, right? Now I've got n times, if n is 1, 2 times 1 is 2, minus 1 is 1. If n is 2, 2 times 2 is 4, 4 minus 1 is 3. It generates the next odd number, okay? So instead of writing n times pi divided by 2, we're going to write 2n minus 1 times pi. This is the equation that generates odd numbers. So 2n minus 1 times pi over 2 is going to be the equation of the asymptotes. I know that's not easy, but you know what? If you have to memorize it, then go right ahead. I'm expecting you to know it. Okay? So 2n minus 1 times pi divided by 2. The domain of the function, the way we're going to write that, really it's theta can be everything but the asymptotes. So we're just going to say theta is an element of negative infinity to infinity, where theta cannot equal 2n minus 1 times pi all over 2. The range of the function is going to be f of theta is an element of negative infinity to infinity. We don't have any restrictions on our y's. We don't have any horizontal asymptotes here. Okay, and let's see, talking about what I expect on the graph, I would expect that you're going to label 3 points. So negative pi and 0, negative 3 pi by 4 and 1, and negative 5 pi by 4 and negative 1. So I've labeled 3 points. I have my asymptotes labeled, and I just need to put my function on there. So this is going to be f of theta, or y, I think it said, is tan theta. Okay? All right, and arrows on the end of each of these parts. Okay. So now what I want you to do is, if you haven't done it already, go to student.desmos.com, type in the code QYR2, and complete that activity. It's helpful, I believe. If you don't have time, I will just go through this summary with you for a few minutes, and we'll just quickly do a couple of examples. So all transformations hold true that you explored for theta in degrees, hold true for angles in radians. And so you should already know the amplitude. This is just review. Amplitude is it's the distance from the equation of the axis to the max or the min. The formula for amplitude is max minus min divided by 2 when we use the variable a. Vertical displacement, that's when you're shifting up or down, and your formula is c equals max plus min divided by 2, and that one we use c for. The phase shift, that's when we shift along the x-axis or the theta axis. Remember, you're taking the opposite sign to get the phase shift. So this would be d units here. The period comes out of the k value, and so you can't pull the period off of your equation like you can for amplitude and vertical displacement and phase shift, but you can generate the period from the formula. So the period is 2 pi divided by k, and k you do pull off of your equation. It's the variable in front of your theta, but remember it has to be factored out, so you're just going to use that formula and calculate the period. All right. Transform the graph of y equals sine x to obtain y equals sine x minus 2. Now, I just want to say very quickly that if you if there are no brackets, you do not assume there will be brackets, right? This means sine of x minus 2. This is a vertical displacement down. So all we're doing really is just subtracting 2 from our y's. So if you want to do it with key points, like you know that it's 0, 0, and then pi by 2. This is, I'm talking about the base function here. Okay. So the base function has these key points. Pi by 2, we go up to 1. Pi, we go back down to 0. 3 pi by 2, we're over at negative 1, and then we come back up to 0. Okay, so if we're subtracting 2 from our y's, we're going to end up with, nothing's going to happen to our x's. That's going to be negative 1, pi, negative 2, 3 pi by 2, and negative 3, and 2 pi and negative 2. So we should have negative 2 as our equation of our axis now, and we'll plot those points. So 0, negative 2, pi by 2, negative 1, pi, and negative 2, 3 pi by 2, and negative 3. Oh. This still should look like the sine curve, right? All that's happened is it's been shifted down 1 and negative 2. And so you can see, if it doesn't tell you how many cycles, that wasn't bad, then I would just go past. I would do 1 cycle, unless it says the domain. It doesn't. So good to go. I'm going to label 5 points always, unless it says otherwise. And y equals sine of x minus 2. So this is x, and this is y, according to the way this was written. Try and stick with the correct variables on here. Okay, that's it for that one. Transform the graph of y equals cos x to obtain y equals negative 3 cos x. So again, I mean, if you want to graph the original and then apply to the points on the original, that's fine too. I'm just going to do it as a sort of a table here. I know that cos x starts at its max, so that's going to be at 0, 1. Then it goes to the x-axis at pi by 2. Then it goes down to its minimum. Then it goes back up to the 0, and then it ends off at its max at 2 pi. So 1, 2, 3, 4, 5 points. That's the base function. Oopsie. And I know, goodness, what's going on? Oh goodness. I know that this is going to be stretched and reflected. So I'm going to have to multiply my y's by negative 3. So you go ahead and do that while I'm fiddling around with this. I don't know what's going on. It's really acting up lately. Okay, I'm just going to pause the video and see if I can fix things. Okay, so let's try again now with, we're multiplying our y's by negative 3. So this is going to be negative 3. This is pi by 2, 0. This is pi and 3. 3 pi by 2 and 0. And 2 pi and negative 3. Okay, so 0, negative 3. So because there was a reflection, now it's starting at its minimum. And then it's going to go to pi by 2 and 0, so it's still at its zeros. And then it's going to go to its maximum, which is up at 3. And it's going to come back down to its zeros, and then back down to its minimum. 0 and negative 3. So there we go. And then I'm just going to, oh goodness. Try to make sure that you understand that that's the minimum, so it's turning there. So if you just did a sort of a branch like that, or an extension down lower, that's going to cost you. Okay, so 5 points labeled, 0, negative 3, pi by 2, see, pi by 2 and 0, pi and 3, 3 pi by 2 and 0, and 2 pi and negative 3. So 5 points labeled, y equals negative 3 cos theta, and our axes labeled would be, did it say theta or did it say x? It said x, so I should really just call this x, call this x, and call this y. Okay, so this is the same old, right? This is nothing new except for the fact that we've got a different x-axis. So now last one, just you go ahead and try to transform the graph of y equals cos x to obtain the graph of y equals cos 2x. Think about what's happening to cos 2x. Where's that 2? What does it do? Pause the video and come back. Okay, so I'm going to start with my base function, which is cosine, so it's going to be 0, 1, pi by 2, 0, pi, so negative 1, 3 pi by 2 and 0, and 2 pi, and back up, oopsie, at 1. Okay, that's nothing. Okay, so now we're going to transform this. How is it being transformed? Well, this is a horizontal compression by a factor of 1/2. So we're going to multiply our x's by 1/2 times x's by 1/2. Okay, so that's going to be 0, 1/2. This is going to be pi by 4. This is going to be pi by 2. This is going to be 3 pi by 4. Really what I'm doing is multiplying the bottoms by 2. And if I multiply that bottom by 2, I get pi. Okay? So I've got the point 0, 1, pi by 4, which is halfway between 0 and pi by 2. So that's going to be pi by, 0, 1, hello. Sorry about that. And then pi by 2, pi by 4 and 0 is here, right? Because pi by 4 is halfway. Pi by 2 and negative 1 will go down here. 3 pi by 4 is here. And pi is up here. So what we've got here, this was cos, yes. What we've got here is one cycle over pi instead of over 2 pi. And I could graph 0, 1, pi by 4, 0, pi by 2, negative 1, 3 pi by 4, and 0 and pi and 1. And this is y equals cos 2x. We've got x and y there. So remember, the period of this graph, y equals 2x, our k is equal to 2, but we're multiplying by 1 over k, right? 1 over 2. So if our k is 2, our period is equal to 2 pi divided by k. So our period of this graph is 2 pi divided by 2, which indeed is pi. So it all makes sense. Okay? All right. I think that's all. Good luck with your homework.